So I want to talk to you guys about manipulating the equilibrium constant. We have to manipulate this if we want to combine different reactions in Hess's law. So let's take a look at a few examples of how this is manipulated. So first, if you want to reverse your reaction, how is that going to affect your K value? So let's take a look. So let's say we're talking about this reaction right here. 2A plus B is in equilibrium with 3C. So just like we talked about today in class, this is how we would write the expression. So that's the forward reaction. If we wanted to reverse this reaction, so instead 3C becomes the reactant and these two guys become the product, like that. So this would be the reverse reaction. We can rewrite the K with our now products on top and reactant on bottom as it's written. So if you guys notice, these two K expressions are just the inverse. So this is the inverse of that equation. So if it's just the inverse, then the general rule then is if you want the K for the reverse reaction, you just take 1 over the forward K. So that's pretty simple. Okay, so if you want to do the reverse reaction, just do 1 over the K, and that'll give you the rate constant, or the equilibrium constant. Number 2, or part B, if we're multiplying reactions, so let's take a look at our basic reaction here. This is our rate constant. If we wanted to multiply this reaction by 2, we could do that. So now instead of 2A, we have 4A, we have 2B, and 6C. We can write the new rate equation. Looks like, okay, I'll just show you the whole thing. Looks like this. So now the coefficients have changed, so we have to change our exponents. We can write this also just like this, where we leave it alone, and then we put the whole thing in parentheses with a 2 out top. So if we can write it like this, that means that whenever you're multiplying a reaction by a certain number, you're just going to bring that K value to the same number. So here it is put into better words. So when reactions are multiplied by a factor of n, the K is raised to that factor n. So if we multiplied the reaction by 2, we raise the K to the power of 2, and that's how you get the new K for the new reaction. Okay, and then for the last one, for Hess's law, if you are combining multiple steps with different K values, to get the overall K value, you're going to multiply the K's for the individual reactions. Okay, this probably doesn't make too much sense yet, but I'm going to show you an example of what I mean. So the example looks like this. So we've got we've got 2 reactions to work with. We have this reaction here with that K value and this reaction here with this K value. And we are trying to make this overall reaction occur. So if you guys remember doing Hess's law, we can actually manipulate these 2 equations to make this one down here. So this is what I'm going to do. So I'm going to take a look. Okay, I know that I need 2 A's on the reactant side of my desired equation. So I'm going to look up here and I'm like, okay, I've got this as a product. I want it to be a reactant. So I'm going to reverse this whole reaction. So if I reverse that, I'm going to have 2A is in equilibrium with 4B plus C. Okay, so that gets me the 2A part of the reaction that I need. And the rest of it isn't finished quite yet. So the next thing that kind of sticks out to me is that I have 2 D's in my required reaction. And I have a D over here in this reaction. So if I just multiply this by 2, I'll be able to have my 2 D's. So that's the next thing I'm going to add is 2 times this reaction right here. So if I multiply this reaction by 2, I'll have 4B plus 2C yields 2D. Okay? So now I've got my 2D part of the reaction I'm trying to make. The 4B's cancel out, which is good because I didn't want them. And then I have 1C over here, which will cancel out with one of the C's here, so that just leaves 1C remaining. And as it turns out, I need that C anyway, so that's a good thing. So now if I add up what I've got left, I have 2A plus C in equilibrium with 2D, which is exactly the equation I wanted to make. So now I've made my equation. Now the question is, okay, what's the new K value going to be for this overall equation? So let's take a look at what we did. This reaction was the reverse of that reaction. So this K is going to equal 1 over this K value, so 1.5. Okay? Again, that 1 over thing I just did was from the first thing we talked about on the prior page, so that's going to equal 2. And then for this equation, I just multiplied this guy by 2. So then here, this k is equal to 3 to the power of 2, which is 9. So now if I want my overall k, I'm going to take 2 and then multiply it by 9. And so my overall k for this new reaction that I just made is 18.